title of our notes today is Attributes of Quadratic Functions. We're going to begin our next unit by analyzing the graph of a quadratic function, which is a parabola. If you don't already have this cut out into your spiral notebook, I need you to hit the pause key and take a couple minutes to draw this parabola into your notebook. Okay, so let's go ahead and get started. So when you look at a parabola, I think the first thing you may notice is that parabolas are symmetrical. Okay, we can draw this line down the middle, and it essentially cuts the parabola in half. And this is what you call the axis of symmetry. When we write the axis of symmetry, you want to express this as a vertical line. So we need to be careful that we don't just say that it's 1. We need to express it as the equation x equals 1. Okay? When you look at a parabola, what you also may notice is that there's a left side and a right side. And on the left side of the parabola is going down, and then it hits this bottom minimum point, and then the parabola starts going back up. Okay, so what we call this turning point right here, where the parabola, okay, kind of changes direction right here, this is what we call the vertex. And the vertex in this case would be a minimum because it's at the bottom of the parabola. And when we express the vertex, we write the vertex as an ordered pair. And we can call the vertex either a maximum or a minimum. So in this case, our vertex is 1, -4. Okay? The next part of a parabola is these 2 points right here where it crosses the x-axis. And this is what we call the roots. All right, they can also be called the zeros of a function. But the roots right here, and I'm going to put in parentheses the x-intercepts, can be expressed as the ordered pairs, -1, 0, and the point 3, 0. Okay, but we write those as ordered pairs. The next intercept you're going to notice is there's a point right here where a parabola crosses the y-axis. Okay, every parabola is going to cross the y-axis. And this right here, we're going to represent the y-intercept as the ordered pair 0, -3. And it does not happen by chance if we look at the equation that there's a -3 right here in this equation. But we'll talk about that more later. So a parabola has a domain and range. What the domain of a function is, okay, if we come up to a function right here, it's the set of all x's that can be substituted into a function, right? It's all those x values that you can input into a function. Well, with a parabola, you can input any x values you want, and you will always have an output. And so what we say is the domain is -∞ to infinity. But graphically, a lot of times, we represent the domain visually by thinking of the domain as the horizontal span of the graph. So right here, we have this middle, and so the parabola is going to go on forever to the right towards infinity, and the parabola is also going to extend forever to the left towards -∞. So if we think of domain more as the horizontal span, I think we can see why that domain would be -∞ to infinity. Now the range, if we look at the function, the range is going to be the set of all y values that are outputted from the function. Visually, the y values can be seen as being the vertical span of the graph. So in this particular parabola, the lowest y value is going to be at -4, and the parabola goes up forever. Try that again. Okay? From -4, and the parabola is going to go up forever towards infinity. And this is what we would consider the range of a parabola. So we would say the range goes from -4 to infinity. So next is the intervals of increasing and decreasing. So we talked about this before, that a parabola is going to go down on one half, and the parabola is going to go up on the next half. So put your pencil on the part of the parabola where the parabola is decreasing. Okay? The part of the parabola that's decreasing is this part right here on the left. And so I'm going to go ahead and write, okay, make a note that this part of the parabola is where the parabola is decreasing. Well, then it hits this minimum value, and the parabola then over here, if you can see, the parabola starts increasing. And so this is going to be the half where it increases. Well, when we give the interval of increasing, decreasing, we want to do this in terms of the x values. Okay, so if you come down here to where we were talking about the domain, that basically the axis of symmetry divides the parabola into a right half and divides the parabola into a left half. The right half goes from 1 to infinity. The left half goes from negative infinity to 1. So what is the parabola doing on the left side? The parabola is decreasing, right? The parabola is going down. And so and then what is the parabola doing on the right half? The parabola is going up. And so we would say over here on the right half, it's increasing. So the way we write this is we would say that the parabola increases from 1 to infinity. And I'm going to use a bracket because it is considered that the parabola begins increasing at the point of 1. Now, a parabola decreases over on the left side. So we say that the parabola decreases from negative infinity to 1. And the fact that you have a bracket on both for increasing and decreasing at 1 means that it is considered at this point 1 to be both increasing and decreasing. Okay? We'll work with that a little bit more. We'll see another example of that. Hopefully that makes a little bit more sense. The last thing that we talk about with a parabola or with a function is we talk about the end behavior. So this is where we start looking at what the ends of the graph are doing. Okay, over here you can see the arrows that I just circled. Well, the best way to describe the end behavior is to get your graphing calculator and to really kind of look at this visually at what the x and the y values are doing. So I'm going to go into my graphing calculator. Let's see, the equation's x squared minus 2x minus 3. So go into your y equals, and let's take this in as x squared minus 2x minus 3. Okay. If you're having any issues with your calculator, honestly, you could probably just watch what I'm doing, or you can go ahead and follow along. Now, what I'm going to go into is I'm going to go into the table, okay? And what I'm looking at with the table is, let's actually hit graph real quick. Let's make sure that we all are looking at the same function, that we didn't type in something incorrectly. Okay, if your graph doesn't look like that, you can always hit zoom 6 and get to the standard 10 by 10 window. All right, so if the graph looks good, I want you to hit second graph, and I want you to go into the table. So what end behavior does is we're going to look at what the y values are doing as your x values get bigger and bigger and bigger. So let's just take a couple minutes, and I want you to scroll down. Okay, you can see there that my x values are getting bigger and bigger. But what I want you to notice is what are your y values in blue doing? Okay, and what I see is that as the x's get bigger, the y values continue to also get bigger and bigger and bigger. Okay, so here's how we write this. I would express this as x approaches infinity. Now that arrow I just made is the mathematical symbol for the word approaches. Okay, it never equals infinity, it's just forever gets bigger and bigger and bigger. And the y values are then approaching infinity because the y values were getting bigger and bigger and bigger, which is why on the right side of a parabola, what we can see visually is the parabola goes up forever. That's what we're saying when we say that the y approaches infinity. We're saying that the parabola goes up forever over on the right side. Now let's go back into our table right here, into our calculator. And you can go ahead and hit the up button, but my calculator is a little slower, so I'm going to cheat a little bit. Let's get back in our table to where the x is 0, and let's start scrolling up and see what happens as our x values get smaller and smaller and smaller. What we're doing here is our x's are approaching negative infinity. Okay, so go ahead and take a look at this, and you can see that as x is getting more and more negative, what the y value is doing. It appears that those y values are getting bigger. And so the way I would express this is I would say as x approaches negative infinity. So we're talking about the left side of the graph. The y values also continue to go to infinity because, again, on the left side of the graph, a parabola goes up forever. So if we look at the arrows, you can see that this is really what we're talking about, is basically saying on the right side of the graph and on the left side of the graph, the y values are continuing to go up forever, so they're approaching infinity. That's a concept that we're going to continue to work on, and we'll get more practice in class. Okay, let's take a look right here at example 2, and let's run through one more parabola, talk about the attributes, and kind of see if we can make a little bit more sense out of this. So first thing we're going to talk about is the axis of symmetry. Let's draw that line. Okay, by the way, if you don't have this picture glued in, again, you need to hit the pause key. You may take a couple minutes to write down this picture. All right, the axis of symmetry, again, we can see this time it goes through x equals -1. So let's make sure we express our axis of symmetry as the line x equals -1. The vertex in this case is a maximum this time. Okay, so this time the vertex is at the top of the parabola, and we would consider this a maximum. Well, the vertex is represented as the ordered pair -1, 4. The roots of the parabola, or the x-intercepts, okay, are going to be the ordered pairs. Again, here's your roots right here, and they're going to be represented by the ordered pairs -3, 0, and 1, 0. Okay? The y-intercept of the graph. Okay. The parabola may not always have roots, but it will always have a y-intercept, and you can see the y-intercept right here is going to be at the point 0, 3. Okay, the domain and range. So a parabola always has a domain of -infinity to infinity. I'm going to actually kind of over here, I'm going to show you a case, just really quick before you come to class, of a parabola that has what's called a restricted domain. So the only time that we are not going to write -infinity to infinity is if we were to have a parabola that had a restricted domain, meaning the domain had, or the parabola had endpoints. So let's say here, it's not very straight. Okay, let's say over here that the parabola has an endpoint at -3, and it stops over here at 4, and there's just part of a parabola that's graphed. Okay, so if the parabola has endpoints, we could then say that the domain is restricted from -3 to 4. But if we see the arrows, we're going to go ahead and go with our -infinity to infinity. All right, so the range this time, the range of the parabola is going to be that vertical span, and we can see that the highest point of the parabola is 4, but that the parabola goes down forever to -infinity. And this is what the range of the parabola is. So we would express the range. We always go from small to big. So it is from -infinity to 4 with a bracket because 4 is included. The intervals of increasing and decreasing. Again, when we do this, okay, we're taking notice that when the y values are increasing, which would be over here on the left side, and then you hit the vertex, and then the y values start decreasing over here on the left. Okay, but the way that that is expressed is we express it through the intervals of x. Okay, so again, this axis of symmetry, -1, divides the parabola into a right side that goes on forever to infinity, and a left side that goes on forever to -infinity. And so, again, this parabola is increasing on the left, so we would express that as -infinity, and it increases all the way up to -1. And on the right side of the parabola, it begins to decrease, so we would express that as decreasing, beginning at -1 and going on forever to the right, which would be infinity. Okay? The last part, let's go over this end behavior one more time, and let's see if we can get the end behavior from the graph rather than having to go into our calculator, although I do like that representation. So when we write end behavior, we're going to express it as x approaches infinity. What are the y values doing? Okay, so let's kind of make ourselves a template this time, because this is what you're going to almost have to memorize, is what the format looks like. As x approaches -infinity, let's go ahead and write with the y values. And so pause for a minute as you write this down. This is what you're going to write every single time you write end behavior. All we're going to do is think about what the y's approach on the right and what the y's approach on the left. So once you memorize that format, we're really only filling in the blank for two parts. So on the right side of the graph, as x approaches infinity, what are those y values doing right here? And I can see that those y values are going down forever, so we're going to say they approach negative infinity. As x approaches negative infinity, now we're talking about the left part of the graph. What are those y values doing? Well, they're also going down forever, so we would say it approaches negative infinity. What's really pretty easy about end behavior for a parabola is that these y values are doing the same thing. They're either both going to approach infinity or they're both going to approach negative infinity. All right, we'll continue to work on this in class, and we'll go from there. I'll see you next time.